Hey guys, welcome back to another problem in the LeetCode 75 study plan series. So today we are on the linked list category for the um, odd even linked list problem. All right, so our instructions are: given the head of a singly linked list, group all the nodes with odd indices together, followed by the nodes with the even indices, and return the reordered list. The first node is considered odd, the second node is even, and so on. Note that the relative order inside both the even and the odd group should remain as it was in the input. You must solve the problem in O of 1 extra space complexity and O of n time complexity. All right, so this is going to be easy. For those of you who might be confused with the instructions, we're not talking about the odd or even values. We're talking about the indices. And we're going to take the nodes at the even indices and the nodes at the odd indices, and we're going to separate them in the two lists, and then we're going to combine those two lists together, and we're going to, by appending the even list to the odd list. So then there you have it. In one singly linked list, we have the odd and the even numbers together. So this example right here does a good job of illustrating what we're doing. Our original list is 1, 2, 3, 4, and 5. With this representing the indices, the values representing the indices, right? And then basically we're going to take the first, the third, and the fifth node, put that in the beginning of the list, and then the second and the fourth node, and put that at the end of the list. Okay, so in order to do this, it's real simple. So let's get to our code implementation. So let's go ahead and check our constraints. The number of nodes in the linked list is in the range 0 to 10 to the fourth power. And this is the value range for the nodes. So notice how the range can be in 0. And I'm pretty sure that's an inclusive range. So that means that our list could technically be 0, which would mean it would be null, because it would just be an empty list, right? So if that's the case, we need to take into account that edge case. So in order to do that, we just need to set up one conditional if statement. So if head is equal to null, then we're just going to return null. All right, that takes care of that. And then so now what we want to do, as I mentioned earlier, we need to create two separate lists, and we're going to basically assign the new list to the head, the original value of the list that we're getting passed in, right? As our parameter right here, right? So we're going to iterate through each list, and we're going to grab the evens and the odds and put them in their respective lists, and then at the end we're going to append the even list, right? So in order to do that, we need to create those new lists. So let's do that right now. So list node odd, and that's going to equal the head. Okay, and then we want to do the even as well. So even is equal to head.next, right? So notice in the instructions how it says the first node is considered odd because it's 1, right? And the second node is even, 2. So we'll set those up, and then there's actually one more that we want to set up as well, and this is going to be called even head. Oops, can't type today. And I'll show you why we're going to use this as we kind of dive into the problem. All right, so now what we want to do is set up our while loop. So this is a singly linked list, so we need to iterate through it just once and basically extract our odds and our evens. So in order to do that, we're just going to keep we have to set up a conditional statement, right, for our while loop for it to keep running, right? It needs to know when to stop. So it's going to stop if the even value is null, or the even value, or my bad, and even dot next is null. We don't have to include odds because we know that the odds are going to come before the even, right? Let's go ahead and take care of just extracting it, right? So, all right, so now what we're going to do is do odd.next, right, is equal to even.next. Okay, so for those of you who are maybe having a hard time understanding what this statement is doing, is okay, so think we have our odd equals head, right? So this is the beginning of our odd list. So the next value is going to be after the even value, right? So it's going to, obviously the sequence of numbers is odd, even, odd, even, odd, even, right? So after the next even value comes an odd value. So that's why we're doing the next in the odd list is going to be the value after the even. And then we're going to do a similar logic for our even value. But first, what we need to do is after that, we need to iterate our odd value to the odd.next. So we can keep iterating through each value in the linked list, right? Because this is a while loop, so we have to keep iterating and pushing our odd value until we reach the end of the list. So now we're going to do that with the even. So even.next is equal to odd.next. Okay, and then even equals even.next. Cool, simple. All right, so what this does is it iterates through our list once, and it gives us two lists, our odd list and our even list, with the nodes, with the odd nodes and the even nodes. So since we want our odd nodes to come first in the list that we're returning, we're going to do odd.next equals even head. So that's why we use this even head right here in the beginning, is because we needed something to keep track of the first node in the even list, and that's what this is, right? So there we have it. We have an odd and an even, and so now all we have to do is return our head. Cool. So let's go ahead and run this. We passed the first two test cases and submit it. Cool. So this is a valid solution in terms of the time and space complexity. So the space complexity is going to be big O of 1 because we're not using any extra space. We're not making any new data structures that require extra space. And then for the time complexity, it's going to be big O of n because we are going through this while loop. We're iterating through a linked list the size of n once, so therefore the time complexity of big O of n. And yeah, that's it for our problem. If you like this video, please go ahead and leave a thumbs up for me. And then as always, just feel free to leave comments in the suggestions. I hope this helped. I hope this helped you to understand LeetCode problems with linked lists better. If you're still kind of having a hard time understanding linked lists, just kind of like wrapping your head around the concept. I know I did when I first started doing LeetCode problems with linked lists. I would heavily recommend that you check out some online resources and tutorials, because it is definitely something that would come up in interviews, whiteboard problems. They're going to ask you these sort of things, these sort of questions. So it's definitely something that you should know. It's a foundational concept in data structures and algorithms. So I'll go ahead and I'll post some resources in the description for you guys if you feel it's necessary for you to keep practicing. If this was a little bit more challenging, or if this category is a little bit more challenging for you in general, then I would highly suggest going over those. So yeah, we'll see you in the next video.